Greetings, math fans. All right, so this is day 2 of probability, and we're just going to get into some different types of probability. So let's get started here. The thing I have on top of this note sheet here, it says the keyword for the following problems is the word and. Okay, and is really important. We talked about or the day before. We talked about it's like a single roll or a single flip of a coin, a single event. And is going to be multiple events or multiple picks or multiple rolls. Okay, it's really, really important you guys understand that. You see the word and. So always look for the word and look for the word or. Okay, so the first thing we're talking about here is independent events. Basically, the second event does not depend on the outcome of the first event. It's really important. They're completely independent of each other. Okay, and so I got this guy right here. This is the mathematics behind it. The probability of two independent events. So if I say the probability of A and B occurring is the probability of A times the probability of B. Okay. An example is if you have a deck of cards, you pick a diamond and you put it back. So here's the key, math fans. The key is always replace. Okay, for independent events, because if I pick a diamond and then I put it back and then I pick another diamond, it doesn't matter what I actually picked in the beginning, right? I could have picked a club and then put it back and then pick a diamond. It's still the same probability. So the key here for independent events, again, you're putting it back because then you're like starting fresh, starting all over again. All right? Dependent events, the second event does occur. It's dependent, right? The second event does depend on the outcome of the first event. So the probability of two dependent events, here's again the mathematics behind it. The probability of A and B occurring is the probability of A times the probability of B given that A has already happened. Okay, it's a little confusing, but it's actually not that bad. So again, you already did something with A. You already picked A. Now I want to find the probability. So the probability is going to change a little bit for probability of B because I already picked A. So an example, same kind of idea. I have a deck of cards. I pick a diamond. I don't put it back. So here's the key. The key is never replace. Okay, so if I pick a diamond and I don't put it back, and then I pick another diamond, well, do you guys agree I have one less diamond to choose from? Right? And I have one less card in general to choose from. So that probability of that second diamond actually is a little bit different. As opposed to the independent events, I pick a diamond, but then I put it back, I have a fresh deck of cards. And so I pick another diamond. So that's why they're independent. This one, I picked a diamond, but I didn't put it back, so now I have less of a chance of getting a diamond because I already picked one of them, right? That's why it's dependent. Okay, so before we actually get into some of the problems, I just want to talk about that. I think that's really important, independent and dependent events. I want to review a few things here because this is actually really, really important for the type of problems we're doing today. So I said here is an important concept from the sequence and series chapter, if you guys remember back in the day. And how many ways are there to arrange these words? And you're like, what? Arrange the words? I remember that. In other words, you can place the words in any order. Oh, look at that. There's a key word there. Oh, man. Highlight that word. How many ways are there to arrange the word Mississippi if I can place the letters in any order? That's an important thing, in any order. Okay. Well, remember, I count the number of letters. There are 11 letters in Mississippi. So it's 11 letters, so it's 11 factorial. And then I count my repeats, right? I have 4 I's. Kind of scary. I really only have 2 I's, but 4 I's here. I have 4 I's, and I have 4 S's, and I have 2 P's. Okay? And you divide that out. Remember, you got to use those parentheses. If you don't use the parentheses, you'll divide by 4 factorial, then you'll multiply it by 4 factorial and 2 factorial and get the wrong answer. Okay, anyway, we get 34,650. Okay, so that's kind of a big nasty word, Mississippi, right? Let's use some more letters that are actually more related to what we're going to be doing in this worksheet here. How many ways are there to arrange if I have the letters XXX? Well, do you guys agree it's 3 factorial and there are 3 of them repeated? So I get 1. Do you guys agree this next one, number 3, there are 3 letters and it's 2 factorial and 1 factorial? Okay, and that gives me 3. And then this one is 3 letters over 1 because there's no repeats at all. So I get 6. Okay? So that's the first thing I want to review. The second thing I want to review, it says, let's review another concept from our last chapter, the counting chapter. Given the numbers 1, 2, 3, 4, 5, how many ways can you choose a 3-digit number without repeats? Well, remember, using the slot method. So it's a 3-digit number. There are no repeats, so how many letters or numbers do I choose from? I have 5 to choose from, and then I use 1, I have 4, then I use 1, I have 3. Okay, so I get 60. So we talked about, remember, independent and dependent events. This is where it's going to kind of come in handy here. Always replace and never replace. So if it's without repeats, I'm not replacing, so no replace. And the next one is with repeats, so this is replace. So just again, kind of get your mind working here, what we're doing. It's the same thing, except again, I'm replacing it, so it means they're independent, right? Okay, we're going to get to that. So do you guys agree it's 5, 5, 5? Because I'm replacing it either time or every time, so I get 125. Okay? So now that we have that quick little review here, let's talk about some of the math problems, some of the probability problems. Okay, now we're going to look at 4 very similar problems. The scenario is the same, but the wording of the question is different. Think in terms of probabilities now. All right, there are 3 nickels, 2 dimes, and 5 quarters in a purse. 3 coins are selected in succession, that means one after the other, at random. Find the probability of selecting a nickel, 1 dime, and 1 quarter. So again, these are independent events because it's in that order. This is, I've even bold or highlighted this here. In that order with replacement. Those are the words you kind of have to think about. In that order with replacement. So do you guys agree, since I'm putting it back, what's the probability? Well, what's the probability of getting a nickel? Isn't it 3 out of 10? Right? And then I put the nickel back, and then I get a dime. What's the probability of getting 1 dime? Well, isn't it 2 out of 10? And then I put that back, and what's the probability of getting a quarter? 5 out of 10. So I multiply all that out, and I get 3 out of 100. Again, you're using your graphing calculator with the fraction button, making sure you give me a nice fraction, all reduced. Okay? So anyway, that's in a specific order. So I know I'm doing a nickel here. I know I'm doing a dime here. I know I'm doing a quarter here. So basically, this is what you have. If I would actually write this out, I have nickel, dime, quarter. Okay? And it's in that specific order, so I don't have to worry about rearranging it. There's no arranging of nickel, dime, quarter. I won't say how many ways can I arrange nickel, dime, quarter, because it has to be a nickel, then it has to be a dime, then it has to be a quarter. Okay? All right, let's look at number 2 here. Same scenario, 3 nickels, 2 dimes, 5 quarters. Same thing, 3 coins are selected at random. Find the probability of selecting a nickel, dime, and quarter in that order. So again, here's the key word here, in that order, without replacement. Now this one's without replacement. So again, it's a specific order. So let's pick a nickel first. The probability of getting a nickel is 3 out of 10, but I'm not putting it back. So I have 1 less coin. I have 1 less nickel, but I'm picking a dime next, right? So how many dimes do I have? I still have 2 dimes, but I have 1 less coin to choose from, right? And then I pick a quarter, and I have 5 of those, and I have, again, 1 less coin to choose from. So I get 1 over 24. Again, it's a nickel, dime, quarter, but it has to be in that order. So I don't have to rearrange it. And again, arrange is what we talked about just a little while ago. You're arranging letters. How many ways can you arrange things? But I don't worry about that. It's in a specific order, so I do not worry about arrangement. Okay, it's like basically back in the day, it's a permutation, because I don't really, order is really, really important here. Okay. All right. Third scenario. There's the same thing. 3 nickels, 2 dimes, 5 quarters. 3 coins are selected in random. Find the probability of selecting a nickel, dime, and a quarter in any order with replacement. Okay, in any order. So that's, again, it's a key word here. So in order, any order with replacement. I'm replacing it. So do you guys agree? It's going to be almost the same as number 1. So 3/10. And I put it back. Probability of getting a dime is 2/10. I put it back. Probability of getting a quarter, 5/10. Now here's the deal. You're like, well, Mr. Curvis, this is the same thing as number 1. Well, this one is in any order. So let's just write out the letters out here. Nickel, dime, quarter. Do you guys agree if it's in any order, I can do nickel, dime, quarter. I can do dime, nickel, quarter. I can do dime, quarter, nickel. I can do quarter, nickel, dime. I can do quarter, dime, nickel. I can do nickel, quarter, dime. Right? I can use actually any one of those 6 scenarios. And you're like, well, okay, well, how do I figure, what do I do with that? Well, since it can be any one of those, you want to multiply it by the number of possibilities. And what we do is, I'm going to let's ignore all this stuff here. So let me erase this just to get rid of it all. Okay, I basically have, here's my word. My word is NDQ. That's why I want you to write it out as a word, because how many ways are there to arrange that? Well, that's what we just did in the previous page of this note sheet. Is that how many ways can I arrange NDQ if it's a word? Well, don't you guys agree? There are 3 letters, and how many repeats? Well, no repeats, so it's 1. Right? There's no repeated letter. And if I did 3 factorial over 1, that's actually equal to 6, which is how many possibilities I just came up with just a minute ago. So what I want to do is multiply this by 3 factorial over 1. Okay? And again, this part right here is when I say in any order. That is important. If you see in any order, you're going to use factorial. Okay? So if I multiply all that out, I get 9 out of 50. So this is a similar problem, 3B, except what I did is I said find the probability of selecting 3/4. So it's the same thing in any order with replacement. Okay? So we're going to do the same thing here. What's the probability? Okay, first of all, it's with replacement. So do you guys agree it's 5 out of 10? And I'm putting it back, so it's 5 out of 10. And I'm putting it back, so it's 5 out of 10. Right? But here, I want you to write this out. Every time you see in any order, I want you to write out the letters. So quarter, quarter, quarter. Okay? How many ways could I arrange that? Well, truly it's 1, but I want you just to write out the mathematics. Right? Isn't it 3 factorial? And how many letters are repeated? 3 factorial. Ah, very good. That's equal to 1. So if I multiply all that out, I get 3/8. Okay, but guys, I want to see this. I want to see what you guys writing out the word like that to then figure out the factorial. Okay? All right, let's move on to 4. Now it's kind of similar, except so it's in any order. So we're going to use factorial. In any order, we're going to use factorial. Okay, very important. But this one's without replacement. Okay, and actually this is the most common type of problem that you have out there. Okay, the reason it's the most common type of problem is because it's like a card problem. When you play cards and somebody deals you, let's say you're playing poker and somebody deals you some cards. First of all, it's in any order. I can take those cards and I can arrange them any way I want in my hand. All right, so it's in any order and it's without replacement. You don't deal somebody an ace of hearts and then take it back and then they might get another ace of hearts. Okay, if they get 2 ace of hearts in a poker hand back in the wild, wild west, they get shot because you're cheating. Okay, so there is no replacement. Again, this is the most commonly used method here, in any order without replacement. Okay, so we have, we're picking 1 nickel, which is 3 out of 10. And then I use one of the coins, which is without replacement, remember. So then there are 2 dimes, so 2 out of 9. And then there are quarters, so it's 5 out of 8. Okay, and again, I want you guys, this is in any order, so you guys should write down nickel, dime, quarter. How many ways to arrange nickel, dime, quarter? Well, there are 3 letters. There's no repeats. Okay, I multiply all that out, I get 1/4. Okay, for B, there are 3 nickels. It's the same thing, except now I'm looking what's finding the probability of selecting 2 nickels and 1 dime. All right. So again, it's without replacement. What's probability of picking a nickel is going to be 3 nickels, so 3 out of 10. Another nickel. Again, I'm not replacing it, so it's 2 out of 9. And then a dime. There are 2 dimes, so it's 2 out of 8. And here it is, nickel, nickel, dime. That's what I want you to write out, nickel, nickel, dime. So then you're just like, oh, okay, there are 3 coins, and I have repeat of nickels, so it's 2 and 1 dime. You don't even have to write the 1 factorial if you don't want to. Okay, make sure if you do, well, this is not a big deal, put in parentheses. Okay, so your answer is 1 over 20. So remember that if it's in any order, you got to use factorial because you can arrange that choice of coins any way you want. Okay, the probability is when you start arranging, giving ways to arrange different things, the probability gets better. It should, because if I said you get a nickel, dime, and a quarter, but you can also get a quarter nickel dime or a nickel quarter dime, or all of a sudden I give you more choices, the probability gets better. But if I said, boy, you have to get it as a nickel, a dime, and then a quarter, the probability is not so great because you got to get it in that exact order. Okay? All right, so those are the 4 scenarios. In any order or in a specific order, with or without replacement. 4 different scenarios. Please understand that. So just real quickly to review this, just because this is so important. Okay, so again, in that order with replacement, if it's in a specific order, I don't have to worry about factorial because it's in a specific order. But if it's with replacement, then it's the completely independent events. If it's without replacement, then they're dependent. And that's why the number of possibilities goes down each time, right? And then for number 3 and 4 was in any order where you have to actually do factorial. Okay, so let's do a bunch of different problems here now. I kind of broke this into the same categories here just to give you some real life problems. And hopefully that helps you guys out. Okay, so anyway, probability. Order is important with replacement. Okay, so again, this is like our first scenario. You have 20 marbles in a jar. 4 are red, 10 are green, and 6 are blue. After you pick a marble, you put it back in the jar. So there's the key, math fans. You're putting it back in the jar. So that means you're replacing it. Okay? And order is important. So it says find the probability of picking a red marble, then picking a green marble in that order. Well, that's pretty easy. It's 4 out of 20 for a red marble, and then a green marble, I'm putting it back, so I still have 20 marbles, so it's 10 out of 20. And since order is very important, it's not like I'm doing red and green or green and red. It's got to be a red, it's got to be a green marble. And then our answer is 1/10. Okay? Find the probability of picking 2 blue marbles. Well, it's 6 out of 20 times 6 out of 20, right? Because I'm putting it back. And we get 9 out of 100. Okay, so again, that's pretty easy. That's any order is important and with replacement. Okay, the next scenario here is order is important, but it's without replacement. That's why they're dependent events, because they depend on what you picked first. So you have a deck of cards. You want to pick a king of hearts to give to your first period teacher. Then you leave the classroom and go to your second period class. You want to pick a queen of hearts to give to your second period teacher. What is the probability of picking those cards? So again, order is important because I want to give the king to my first period teacher and I want to give the queen to my second period teacher, right? So order is important. You don't want to give the queen to your first period teacher, okay? All right, and it's without replacement because once I hand that card to my first period teacher, I walk out of the classroom, my first period teacher's got the king of hearts, and I'm looking for, I don't have that in my deck anymore. That's why it is without replacement. So that's pretty easy, right? The probability of picking a king of hearts is 1 out of 52. And by the way, the word and is used here. So I'm picking a king of hearts and a queen of hearts. Okay, so that's why it's multiplication. I have 1 king out of 52, but now I've chosen a king. So the king is not in there, right? But what am I picking? I'm picking a queen, aren't I? So it's 1 queen, but I only have 51 cards because I have 1 less king. This deck is missing the king. Okay, so multiply that out. I get 1 over 2652. Okay, 2B, the same problem as above, except you want to pick a blackjack to give your first period teacher, a queen of clubs to give to your second period teacher, and then a red card to give you your third period teacher. What is the probability of picking those cards? So it's kind of the same idea. A queen of... I want to pick a blackjack to give to your first period teacher. Well, how many blackjacks are there? That's why you need to know the cards, right? There are 2 blackjacks, so it's 2 out of 52. And then I want to go and give a queen of clubs to my second period teacher. Well, guys, I don't say I use 2 cards. I only picked one of those blackjacks. So I really have 51 cards left over, and I'm picking 1 queen of clubs, only 1 queen of clubs. And then I go and pick, I want to give a red card to my third period teacher. Well, I only have 50 cards to choose from, and I haven't picked any red cards yet, have I? So how many red cards do I have to choose from? I have 26 red cards to choose from. There, half of them are red, right? 26. But make sure this number down here, make sure this number shrinks 52, 51, 50, because again, it's without replacement. That's important. Okay? All right, so I multiply all these guys together, and I get 1 over 2550. Okay? All right, number 3. Okay, now we're getting into any order. It's important. Any order means I am going to use factorial. Okay, a bottle contains 40 marbles, 20 are green, 13 are red, and 7 are white. A set of 3 marbles is drawn from the bottle. Each time a marble is chosen, it is replaced. What is the probability of choosing 3 green marbles? So what I want you guys to do is write out green, green, green. So again, I'm replacing it. They're independent. I keep putting it back. So do you guys agree? It's 20 out of 40 times 20 out of 40 times 20 out of 40 times 3 factorial over 3 factorial. And I know some of you guys are saying, well, Mr. Curtis, why am I doing 3 factorial over 3 factorial when it's just equal to 1? Why do I have to write that out? Well, you know, it's good habit, because if you know that it can be in any order, say how many ways can I arrange GGG? Okay, so it's just kind of a good habit to do that. Anyway, I get 1/8. Okay, so we have a green, a red, and a white. So probability of getting a green is 20 out of 40. Again, they're replacement, so it's times 13 out of 40 for a red, times 7 out of 40 for a white. Okay, and then I have 3 marbles, so it's 3, and there's no repeats. So I get 273 over 1600. Okay, again, if you notice, all these are fractions. Okay, so make sure you always give me a fraction, unless you hit your fraction button and it basically gives you a decimal, which means the calculator can't handle such a long fraction or such a complex fraction. Okay, next one, 2 green and 1 red. So green, green, and red. So again, it's with replacement, so it's 20 out of 40. And another 20 out of 40, because 2 green and a red, 13 out of 40. And then 3 factorial, green, green, red. And then I have 2 greens and 1 red. Again, parentheses are important. And we get 39 over 160. Okay? Okay, letter D, that is such a key word. Please don't blow that off. At least, here's underline. On a quiz or test, I'm not going to underline it. Okay, you guys got to recognize it. At least 2 white marbles. So you either have white, white, and I'm just going to put O for other, or you have white, 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 because you're picking 3 marbles. Okay, and if it's at least, it's either that or that. Okay, so it's plus. So let's do it. We got 7 out of 40 for a white, 7 out of 40 for a white, and other. Well, how many others are there? Aren't there 33 others? Right? And then ways to arrange it. Well, aren't there 3 letters and then 2 W's and 1 other? Okay? And then 3 W's is going to be 7 out of 40 times 7 out of 40 times 7 out of 40, right? Times 3 factorial over 3 factorial, because they're all being repeated. And this one is one where you, it's just too complicated. It won't give you a nice answer. So my answer came out to be 0.0812. Okay? All right, so that's the first 3 types of probabilities. And now we get into, again, I said the most common one, which is any order without replacement. Again, if you're not sure which one the most common one is, just think of cards. Your dealt cards. If I deal you, an ace, a king, an ace, a king, and an ace, you can't go, oh, geez, I have nothing here. You go, oh, gee, I got 3 aces, and you move the 3 aces to one part of your hand and the 2 kings to the other part, and you got a full house. It's an awesome hand to have. Okay. All right. So just remember that any order without replacement, most common probability. All right. 2 cards are drawn at random from a standard deck of 52 playing cards with no replacement. What is the probability of drawing 2 jacks? Well, do you guys agree that probability of drawing a jack, there are 4 of those, so it's 4 out of 52. And I'm picking another jack, but there's no replacement, so 3 out of 51. The bottom, 1 less jack and 1 less card total. And basically what you have is, let me write this out, jack, jack. So that's just going to be 2 factorial over 2 factorial. And you get 1 over 221. Okay? B, what is the probability of drawing a queen and a king? So queen and king. So it is 4 out of 52. That's a queen. And then a king, I still have 4 kings, but I have 1 less card. So you've got to remember that. The one before it, A, it was 2 jacks, so I have 1 less jack each time. This one I still have 4 kings. So it's times 4 out of 51 times 2 factorial, because 2 letters, and 1, because there's no repeats. And I get 8 over 663. Okay? Number 5, from a group of 3 girls and 4 boys, a committee of 2 members is to be selected. What is the probability of a committee consisting of a boy and a girl? So let's write this out. A boy and a girl. So do you guys agree? Because if in any order, it could be a boy or a girl or a boy, right? So that's why you got to look at both of those. Well, by using the method here that I taught you, that you take that into account. So anyway, probability of getting a boy is 4/7, because there's 7 people total. And then the probability of getting a girl, it's 3, because there's 3 girls and 1 less person to choose from. And then of course, BG means 2 factorial, and there are no repeats. So it's divided by 1. So you get 4/7. Okay, 2 boys. So BB, it's going to be 4/7 times 3/6. Okay, because again, I'm choosing 1, it's 1 less boy, right? Times 2 factorial over 2 factorial. Which is like saying 1, because if you pick a boy and boy, or a boy, it's the same thing, right? All right, and we get 2/7. And the last one is girl, girl. So it's going to be 3/7 times 2/6. And then, of course, that's 2 factorial over 2 factorial, because they're both, it's 2 letters, and they're both being repeated. And we get 1/7. Okay? Not bad. Let's look at number 6 here. A bottle contains 40 marbles, 20 are green, 13 are red, 7 are white. A set of 3 marbles is drawn from the bottle. What is the probability of drawing 3 green marbles? So again, green, green, green. So it's 20 out of 40. We use one of those green marbles, so it's 19 out of 39. Use another green marble, it's 18 out of 38. And then it's 3 factorial, because there are 3 green, and we're using all 3 letters. All 3 letters are being repeated. And we get 3 over 32. Okay, a green, a red, and a white. So green, red, and white. Okay, it's going to be 20 over 40 times 13 over 39 times 7 out of 38. Again, that bottom number is being decreased because we keep using a marble. And then it's 3 letters, and there's no repeats, so it's divided by 1. And that gives you 7 over 38. Okay, 2 green and a red. Okay, it's going to be 20 out of 40. And another green, 19 out of 39. And then a red marble, which is 13 out of 38. And there are 3 letters to choose from. The green G's repeated twice, and the red's repeated 1 time. So we get 1/4. Okay, and then D, there's that word again, at least. So basically what you do is you have, for picking 3 marbles, so it's white, white, and some other one, or white, 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 right? Okay, so we have 7 out of 40 times 6 out of 39, and then other, right, there are 33, so there are 20 green and 13 red, so it's 33 out of 38, right, and then WWO is going to be, right, 3 factorial divided by 2 factorial, 1 factorial. Okay? And then it's because it's at least, it says that group or that group, that's why it's plus, right? Very important. Don't multiply everything together, it'd be bad. So then we get 7 out of 40 times 6 over 39 times 5 out of 38. And then the white ones, it's 3 factorial and 3 factorial. And then if you multiply all that out, you get 7 over 95. Okay, so watch out for that word at least, or no more than, or up to, or whatever, because make sure then it's multiple possibilities, and that's why you're going to use or, which is then addition. All right, so that's it, math fans. That's a lot of stuff with probability. It really teaches you the 4 scenarios of probability, with order, without order, with replacement, without replacement. So it's a lot of practice with all this stuff. So anyway, that's it, math fans. Have an outstanding day. Adios. Goodbye.